Hello all. Today in this class we discuss about the communication systems and the different types of communication procedure in electronics and telecommunication. So first of all, today our topic is communication. So first of all, in this class we just elaborate the basic fundamental nature of the communication, different types of communication. First of all, communication can be divided into two categories. First is the analog communication and second one is digital communication. In the analog communication there are different types of modulations or transmitter engine which is generated in the transmitter end. First is known as double sideband suppressed carrier. Second one is known as double sideband full carrier. Number 3 is conventional AM. Conventional AM is a procedure by which our AM wave is broadcast from one point to another point. Number 4 is single sideband suppressed carrier, and number 5 is vestigial sideband. So these are the analog communication, but these all technique of communication or in the transmitter end, this type of communication hardware is designed according to the variation of the carrier amplitude, because in a communication there are basically two waves exist. One is EM cos omega mt. This is denoted by modulating signal or baseband signal. This is known as XT. This is also known as information signal, where EM equals to the modulating voltage and omega m equals to the modulating frequency. And carrier frequency is represented by, carrier frequency means the signal which carry the information of this baseband signal. So depending on this carrier, if we write the typical equation of the carrier signal, then this is the mathematical expression. When the carrier amplitude vary according to the amplitude of the modulating signal, then this is known as amplitude modulation. When frequency is varied, called frequency modulation. When phase is varied, is called phase modulation. So basically in analog modulation there are also one features are available called angle modulation. These all are known as basically amplitude modulation. These all are, but in angle modulation there are two different types. One is frequency modulation and one is phase modulation. Okay, phase modulation. But in digital communication, first of all we convert the analog continuous signal to analog discrete signal. So this is done by the help of sampling theorem or sampling process or sampling technique. After getting the sampling technique, we use different types of transmitting end hardware like a pulse code modulation, pulse position modulation, pulse width modulation. Different types of approach are used in a digital communication. So there are so many advantages of digital communication over the analog communication, because in a digital communication the noise level is very reduced and digital communication is more secure than the analog communication. And it is very important that in today's technology there are lots of digital communications are available, and 90% technology are depend on this digital communication technology. So for technical improvement, digital communication is always better than the analog communication. And depending on the signal types, there are basically 4 different types of signal exist. First signal is known as analog continuous signal. This is analog continuous. This signal is represented by this equation, y equals to a sine of omega t. So this is the amplitude plus a, and this is the amplitude in the negative side minus a, and peak to peak value is 2a. So this is the analog continuous signal. So next we talk about analog discrete signal. So analog discrete signal means we just sample of this waveform. We just take the sample of this waveform, okay, in a periodic time or interval. So it is represented by y of n sample of a of sine omega n. Okay, so this is also minus a and this is plus a. But here look that in a continuous signal, the amplitude is present at every instant of time, but when you sample it, the number of samples depend on the sampling nature of this signal. So that's why we hear the improvement of mathematical equation that is represented by sine omega n. So this is analog discrete signal. Okay, so now next one is digital continuous signal. Digital continuous signal. Digital continuous signal means it look like a square wave, where this is represented by 1 0 1 1, and this is a time domain t, and this is represented by xt, that means as information. So xt equals to 1 for 0 to t by 2 to t, when 0 to t by 2, and this is 0 when t by 2 to t. So this is or instead of 1 we represent in a voltage form, that is the magnitude is equal to voltage. So this is known as digital continuous signal. So next we talk about digital discrete signal. This digital discrete signal is application in a digital signal processing, or also known as DSP. It's look like that. There is a no periodic pattern. Okay, these are the sample n equal to 0 1 2 3 4 5, and say for this is 1 amplitude, this is 1.5, this is 2. Okay, this is also taken by minus 1. So we represent in a tabular form. This is x and this is x of n, this is x of n, and this is the n, where n represents 0 1 2 3 4 5. What is the value of xn? Xn at 0 this is 1.5, at 1 this is 1, at 2 3 equals to minus 1, 4 equals to 1, 5 equals to 1. That means at every sample what is the value of this magnitude, but there is no periodic nature. Okay, so these are the 4 basic fundamentals waveform for analyze different types of purposes in our communications. Okay, next one is there are also different types of signal are used in a communication. Number 1 is single sided exponential function. So what is its nature? The nature is that single sided exponential function means this is a time and this is a function ft, and it look like that, and we assume this is e to the power minus at. That means the highest amplitude is given by e at t tends to 0. That means from the definition this ft equals to e to the power minus at t greater than equal to 0 and 0 when t less than 0. So this is single sided exponential function. And what is the value of a? This a is the slope of this curve. Okay, now we talk about double sided exponential function. Double sided exponential, this is a short form exponential function. I just write in a short form, this is a fn mean function. So in a double sided exponential function, basically in the two sides present this signal, this is t greater than 0 and this is t less than 0. So this is represented by t e to the power at, and the highest amplitude is a, and this is t tends to infinity and this is t tends to minus infinity. So what is the definition? Definition is if t is equals to e to the power minus at when t greater than 0 and e to the power at when t, this is also equal to sign also representation. So this is the form of double-sided exponential function. Okay. Next one is known as, third one is known as impulse function. Impulse function means, that means this function only exists at t tends to 0 and the value is 1 and 0 otherwise. That means instead of t equal to 0, no other value is represented in the time domain. So this is plus infinity and this is minus infinity. Okay, this is called impulse function, or also known as delta function. This impulse are also known as delta function. Number 4 is constant function. Constant function. Constant function means from minus infinity to plus infinity, at every instant the amplitude is always constant. That means ft equal to, that means y-axis will represent by ft. Ft equals to a from minus infinity to plus infinity. Okay. Next one is number 5. Number 5 is unit step function. Unit step function is also known as DC function. This is a value of k and this is t. That means ut, this is for y-axis name of the signal. This equals to k when t greater than 0 and 0 when t less than 0, and this is when k equals to 1. This is known as unit step because the value is unity. Okay. Number 6 is known as signum function. Signum function. Signum function is represented by, this is a plus 1, this is a minus 1, this is t greater than 0, this is t less than 0, and ft is a y-axis mathematical notation represented by, this is plus 1 when t greater than equal to 0 and minus 1 when t less than 0. This is known as signum function. Next one is number 7, is known as get function. Get function is represented by this waveform. This is minus t by 2 to plus t by 2. This is a. So get function represented by gt is equals to a from minus t by 2 to plus t by 2. Okay. So this is the, we represent the different types of signals which is used in a communication, and one of the most important signal is radio frequency signal. Radio frequency exponentially decay signal. So radio frequency signal is basically represented by any sinusoidal waveform. And what is exponential? Exponential decay. This is exponential, not delay, sorry, decay. That means this is exponential, and if we product of this or modulate by this wave, by exponential waveform, then we know that in a sine wave there are two envelopes are present. One is positive envelope and one is negative envelope, because the highest value of sine is plus 1 and negative value is minimum value is minus 1. So in between them the sine wave is very look like that. So this is the time t. So this is called radio frequency signal or radio frequency decay signal, because at the increase of time the amplitude of the radio frequency signal is decreases. Okay. So these are the lots of various features, various types of signals, which is very important for users to analyze the communication purposes. So in this class we just talk about the basic communication structure. Okay, how communication, different types of communication are exist in a communication systems, and what are their function. In the later video we will discuss about that, and different types of signals which are used in a basic fundamental types in a communication systems. Okay.